You're on site, the soil has been placed, and it's time to compact. You see a smooth drum roller, a sheep's foot roller, and a plate compactor. Which one do you choose? This isn't a trivial decision. Picking the wrong compaction machine is one of the fastest ways to waste time, money, and fuel while creating a weak and stable base that will fail under the first load. The secret to effective compaction isn't just about weight. It's about matching the machine's action to the soil's particle size and cohesion. In this video, we're moving beyond the equipment names to the underlying soil mechanics. We'll break down the different types of compaction machines, explain the physics of how they force soil particles together, and give you a simple decision matrix so you'll always know which machine to deploy for sand, clay, or a mixed granular base. By then, you'll be able to look at a soil sample and immediately know its perfect compaction partner. Let's start by understanding the three fundamental mechanisms of compaction: static weight, vibration, and impact. Static compaction relies on pure, dead weight to compress the soil layers beneath it. It's effective but limited to the upper layers. Vibratory compaction uses a rapidly rotating eccentric weight to send high-frequency shocks through the material. This agitation reduces friction between soil particles, allowing them to settle into a denser configuration under the machine's static weight. Impact. Compaction, like a rammer, uses a pounding action to deliver high-force, low-frequency blows. Each mechanism is king for a specific type of material. The first and most common category you'll see on almost any project is the roller, but not all rollers are created equal. The most versatile and widely used roller is the vibratory smooth drum roller. This machine has one or two large, smooth, metal drums that house the vibrating mechanism. Its primary action is a combination of static weight and powerful vibration. This makes it the undisputed champion for compacting granular soils like sand, gravel, and crushed stone. The vibration is exceptionally effective at rearranging these non-cohesive particles into a dense mass. It's also the standard finish roller for asphalt pavements, providing a smooth, sealed surface. However, a critical pro tip is to never use a smooth drum vibratory roller on cohesive soils like silt or clay. The vibration will simply create a phenomenon called overmanipulation, where the clay becomes plastic and loses all its shear strength, turning your subgrade into a muddy, unstable mess. It's a classic and costly on-site mistake. So, how do you compact cohesive soils? You use a sheep's foot roller or its modern equivalent, the padfoot roller. Instead of a smooth drum, these rollers have a surface covered with many rectangular or round-shaped protrusions, called feet or pads. The principle here is kneading and compaction by pressure. The small, concentrated feet penetrate the top layer of the cohesive soil. Applying extremely high pressure at their tips, this pressure shears the soil, breaking down clumps and forcing the particles together. As the roller passes, the feet sink in, compacting the layer from the bottom up. With successive passes, the padfoot roller will walk out of the lift as the soil density increases. This kneading action is the only effective way to achieve proper density in clay soils without creating a spongy, weakened layer. An efficient workflow secret is to use a padfoot roller for the main compaction of clay lifts, and then make a few final passes with a smooth drum roller to seal the surface and create a smooth working table for the next operation, for confined areas where large rollers can't reach. We have a different set of machines. The vibratory plate compactor is a powerhouse for small jobs. It's a self-contained unit with a large, flat base plate that vibrates, making it ideal for compacting granular soils in trenches, around foundations, and behind retaining walls. They come in different sizes and amplitudes. A higher amplitude is better for thicker lifts of gravel. For cohesive soils in trenches, the trench rammer or jumping jack is the tool of choice. This machine uses pure impact force. A large foot is propelled by a gas or diesel engine, slamming into the soil in rapid, successive blows. This pounding action is highly effective at consolidating cohesive soils in deep, narrow trenches where kneading action is needed. A pro tip for using a rammer is to overlap each pass by half the width of the foot to ensure uniform compaction and avoid missing spots. For the heaviest duty applications, we look beyond conventional rollers. The pneumatic tire roller or rubber-tired roller uses a set of inflated, Rubber tires as the compaction element. The primary action here is a combination of static pressure and a kneading action as the tires flex. This makes it excellent for compacting a wide range of materials, from mixed soils to asphalt. The kneading action helps to close voids on asphalt mats without fracturing the aggregate. At the extreme end of the scale is dynamic compaction, a ground improvement technique where a massive weight, often 10 to 20 tons, is dropped from a great height of 10 to 20 meters onto the ground surface. The tremendous impact energy densifies weak, loose soils to significant depths, sometimes over 10 meters. This is a specialized technique for pre-treating large sites like port facilities or industrial yards before construction. To summarize the key takeaways: 1. Use vibratory smooth drum rollers for granular soils and asphalt finishing. 2. Use padfoot to sheepsfoot rollers for cohesive clay and silt soils to achieve proper kneading action. 3. For confined areas, use vibratory plates for sand and gravel, and rammers for clay in trenches. And 4. Always remember that the goal is to reduce our voids, and the machine is just the tool selected based on the soil's personality. Now I want to hear from you in the comments below. What's the most challenging compaction problem you've ever faced? Was it a deep layer of uniform clay, a mixed soil with boulders, or achieving density in a tight, confined space? Your field stories are the best learning tools. If this guide to compaction equipment has helped you understand the why behind the machine choice, please give this video a like